Hello everyone, welcome to our presentation. Today we are presenting a comparative analysis of containerization and virtual machines, focusing especially on security and efficiency trade-offs. This research and presentation were prepared by our team, Mehmet Yiğiter, Irmak Göktaş, and Hacer Şakiroğlu. Cloud computing is the standard today, but behind the scenes there is a constant battle between two technologies. On one side, we have traditional virtual machines, and on the other side, we have modern containerization. In this video, I will start by explaining the history and architecture of virtual machines. After that, my teammates will explain the containers and give you our final comparison results. Let's begin. First, to understand why we use containers today, we must look at the evolution of deployment. Let's go back to the past, to the traditional era. In the past, companies used one physical server for just one application. Imagine you buy a very expensive, powerful computer, but you only use it to run a calculator app. The rest of the computer does nothing. This model was expensive and it wasted a lot of computing power. To solve this waste problem, the virtualization era began. Virtualization changed everything. It allowed us to run multiple systems on a single physical machine efficiently. Instead of one server for one app, we could run 10 or 20 apps on one server. For many years, virtual machines were the only solution for this. However, recently, we are seeing a shift. We are moving from heavy virtual machines to lightweight containerization. This is popularized by tools like Docker. So, our goal in this presentation is to compare these two based on three things: efficiency, security, and manageability. Which one is better? Let's find out. Now, let's look at the technical foundation. This is the virtual machine architecture. What is a virtual machine? A virtual machine is basically a software emulation of a physical computer. It acts like a real computer, but it is just a software. There are two critical components here. First, the hypervisor. As you can see in our report, the hypervisor is a software layer. It sits between the hardware and the virtual machines. There are even two types. Type 1 is which installs directly on hardware, and there is type 2, like a VirtualBox, which you might use it on your own laptops. And second, and most importantly, is the guest operating system. Please pay attention here. Every single virtual machine includes a full operating system, like Windows or Linux. This includes its own kernel, its own drivers, and its own libraries. So, what is the result of this architecture? Isolation is excellent because every virtual machine is separate. However, this creates a problem: high resource usage. Because every virtual machine runs a full kernel, they are very heavy. They use a huge amount of RAM and CPU just to keep the operating system running. This heaviness is exactly why containerization was invented. Now, let's see how containers solve this problem. Now, let's look at the solution: container architecture. The most important difference is right here: no guest operating system and no hypervisor. Unlike virtual machines, containers do not carry a full operating system inside them. Instead, they use a container engine, like Docker. This engine allows all containers to share the host operating system kernel. This is the magic part. Because they share the kernel, they don't need to boot up a new operating system every time. So, what is inside a container? It includes only the application and its dependencies, like libraries, nothing else. You might ask, if they share the kernel, how they are separated? They use two Linux features. First, namespaces. This provides isolation, so one container cannot see another. And the second one is cgroups. This sets resource limits, so one container cannot use all the CPU. To summarize, virtual machines isolate the hardware, but containers isolate the process.
Now I will talk about performance and efficiency. Let's begin with resource utilization. One major drawback of virtual machines is resource overhead. Imagine running 10 VMs on a server. Your memory is now holding 10 operating systems and 10 separate kernels at once. This makes the system unnecessarily heavy. Containers, however, work differently because they share the same kernel. There is no duplicated operating system code. As a result, we achieve what is called high density, meaning we can run many more containers than VMs on the exact same hardware. So businesses make much better use of their existing infrastructure. This efficiency also affects startup speed. When you start a virtual machine, it behaves like booting a physical computer. Drivers load, services start, and this process typically takes minutes. Containers, on the other hand, are almost instant. Since the operating system is already running, launching a container usually takes milliseconds or seconds. And this speed advantage is especially valuable in scalable platforms or microservice architectures. Next, let's talk about storage. Virtual machines use persistent storage, stored in virtual hard disk files. This means that even if the VM shuts down, the data remains, making VMs ideal for databases or systems where long-term data consistency is needed. Containers are designed to be temporary. So, by default, when a container is removed, its data is lost. To keep data, developers must configure storage manually using volumes or bind mounts. So, persistence is possible with containers. It just requires extra configuration. Now, let's move on to the networking. Because even if a system is fast, communication still needs to be reliable. In virtual machines, networking is quite straightforward. Each VM behaves like a completely separate machine. It gets its own IP address and MAC address, so it interacts with the network just like a physical computer would. This makes VM networking highly compatible with traditional architectures. Containers work a bit differently. Instead of each container having its own identity, they typically share the host's IP address and operate through different modes. For example, it's bridge mode. In bridge mode, containers communicate within a private internal network, kind of like having their own neighborhood. In host mode, containers use the host machine's network directly, almost as if they live on the host itself. One important consideration is that bridge mode usually involves network address translation, which can introduce slight performance overhead. So, while containers provide flexibility, networking must be configured thoughtfully to avoid bottlenecks. To summarize, containers offer outstanding speed and efficiency, while virtual machines provide stronger persistence and isolation in certain scenarios. Now I will hand it over to our next speaker to continue with the security aspects.
Now I will talk about the security part of our comparison. One important topic here is isolation, which means how file systems stay separated. In the virtual machines, isolation happens at the hardware level. the hypervisor creates as a strong barrier, so it's a very difficult for an attacker in the one virtual machines, host or another virtual machines. This gives virtual machines very safe and stable structure. Containers work differently. They use namespace to separate processes, but they still share the same kernel. Because of that, containers isolation is weaker. So, in the general, virtual machines offer stronger protection than container. Critical risk. This weaker isolation brings some risk. The biggest risk is the shared kernel. If the kernel has a big problem or a security issue, all the containers can be affected at the same time. Another risk is a container breakout. An attacker escapes the container and reaches the host. To reduce this risk, we use security container technologies. For example, Kata containers. Kata containers run container inside lightweight virtual machines. This gives an extra security while still keeping container experiences fast. So it's a like middle point between virtual machines and the normal containers. Now, let's look at how we management system, virtual machines management. Virtual machines follow the path model. They live for a long time and we take care of one by one. If someone breaks, we try to fix it. So managing virtual machines can take more time and the manual work. Containers follow the cattle model. They are short-lived and easy to replace. If one fails, we simply create a new one instantly. Kubernetes helps a lot of here with auto-scaling, self-healing, and load balancing. This makes container environment very flexible, easy to manage. No single winner. So which one is better? Actually, there is no single winner. Both options have their own strengths and weakness. The right choices depends on the needs of the system, the workload and the security level you accept. If many real project companies even use it at both time and the same time. Okay, we choose virtual machines when we need strong isolation and high security. They are also the best choices when we want to run different operation system on the same physical server. So, virtual machines are very useful in environment that must stay stable and protected. We chooses containers when we want the speed, efficiency, and portability. They start very fast and use favor resources. They work great for microservers and modern DevOps pipelines. So, for teams that need fast deployment, containers are the usually better option. Future. In the future, we accept to see more hybrid approach. For example, running containers inside lightweight virtual machines. This gives us a strong isolation of virtual machines, but keeps to the speed and flexibility of containers. This hybrid direction is becoming more common, and we think it will be continue to growing in the coming years. That's all. Thank you for watching this presentation. We hope to explain it is the topic clearly and simply. If you would like to explore more details or compare other technologies, you can check the project report. Thank you for again.